Welcome to Eureka Math. This is Mr. Schenkel. I'm going to be helping you today with Algebra Module 1, Lesson 26. Let's get started. In the first few tables here, the example in exercise 1, we're going to just fill out some tables where we double the number that we start with and then add 5. And we're going to follow that pattern and then use that later to talk about our lesson today. So here's how this works. We're going to start with our first number, which is a 1, and then we're going to double that, and then add 5 to it, and eventually we're going to get our result of round 1, which is a 7. And then that 7 is going to be the first number, the number we start with in our second round. So at that point, let me back this up, we're going to start with the 7, and we're going to double that, so 7 times 2, and then we're going to add 5 to that, and 7 times 2 is 14, and 5 more is 19. So the second number, the result of round 2 is 19. And then, of course, that becomes our first number in the third round, so this is a 19. And then we just send it through and have it do the same thing. So it's 19 doubled, that's 38, plus 5, and that's 43. And then that number is going to start our next round. So 43 times 2, that's 86, plus 5 is 91. And then that starts our last round, which is 91 times 2, 182, plus 5, 187. All right, so we started with the original number, doubled it, added 5, got a result. That result began our second round, and so on. That's going to continue to repeat. All right, exercise 1, we're going to do the same thing, only this time we're going to start with the number 2 instead of the number 1. So let's see, 2 times 2 plus 5 is 9. That becomes the first number of the second round. 9 times 2, 18, plus 5 is 23. And then we start with the 23. 23 times 2, that's 46, plus 5 is 51. Okay? Got the idea? Third one, start with the 3. 3 times 2, 6, plus 5, 11. 11 starts our next round. 11 times 2, 22, plus 5, 27. 27 starts our last round. 27 times 2, 54, plus 5, 59. All right, so we got that idea. Let's use that. In exercise 2, we're going to do the same thing, double and then add 5. But the goal of this game is to find the smallest starting whole number that will produce a result of 100 or greater in 3 rounds or fewer. 100 or greater in 3 rounds or fewer. Well, I know starting with 1 didn't work and starting with 2 didn't work. In fact, we can take a look at those. If I started with a 2, I ended up with 51. If I started with a 3, I ended up with 59. So it's going to have to be bigger. I'm going to guess 8. And in order to do this, I want to make myself a little table here. So this would be my number, my starting number. And then I'm going to double it, and and add 5. And that will get me a result. So I'm going to start with 8, just as a guess. So I'm going to take 8, and I'm going to double it. So 8 times 2 is 16, plus 5 is 21. And then that's the beginning number of my second round. 21 times 2, that's 42, plus 5 is 47. Oh, it looks like I'm going to be a little short. That begins my next round. 47 times 2 is 94, plus 5 is 99. Oh, I just fell short. So my beginning number must have to be a 9. Let's try that, see if that, obviously it will. Let's see what our answers would be. This is my number, this is my double, and add 5. So if I start with a 9, 9 times 2 is 18, plus 5 is 23, and then 23 is my next number. 23 times 2 is 46, plus 5 is 51, and then I start with 51. 51 times 2 is 102, plus 5 is 107. So yes, 9 is the smallest starting whole number that will give me over 100 by round 3. All right. Oh, by the way, what if we had to do the smallest starting number that would result in a round 3 result of 1,000? Well, that makes things a little tougher, right? I mean, we were able to guess and check on this one because we were close to begin with, so we didn't have to go too far. 1,000's a different thing. I don't know where I would start. Maybe, gosh, I got to 100 here, 107 in 3 turns with a 9. So I don't know, maybe 20, I don't know, 30? Is 40 too much? Is it not enough? I'd have to really do some checking, and I'd have to do a lot of guessing and checking. Well, it would be nice to be able to not have to guess and check and be able to have an equation where I could model this situation with an equation and then find out no matter what I wanted to. So we're going to work on that. So here's exercise 3. In exercise 3, what we're looking for is a generic initial value of a sub 0. Well, a sub 0, let me back up a little bit. Let's say before we do this exercise 3, let me give you this. Let's consider one of these tables where we have a starting number and we have the double and then add 5. That's an N. Double and add 5. And then let's get an equation for each one of these. Okay, and then hopefully we can write an equation that will work for all the situations. So let's say, for example, that we're starting with a 5. Let's just choose a number. We don't necessarily know what number we're starting with. I just randomly chose the 5. And let's say that that is our starting number, and let's call that a variable because we don't know what it is. So it could be anything. So really I want it to be a variable. And we're going to use the number 5 just to help keep us going on the pattern until we can figure out the equation. So let's call it a sub 0. And that'll be our initial number. the very first number before we do any rounds. That means what A is at round 0, okay? And then let's perform what's happening to our first initial number. So we're going to take the number, we're going to double it, and then we're going to add 5. So 5 times 2 is 10 plus 5 is 15. So if I take that first number 5 and I double it and add 5, I get a 15. Well, let's write an equation for this situation if we didn't know what the initial number was. If we didn't know that it was a 5, well, wouldn't it be the 5 would be A sub 0, so the number we start with. Wouldn't we multiply it by 2? And then wouldn't we add 5? And then wouldn't that be the answer? And wouldn't that answer be the beginning of the next round? That would be the beginning of the next round. Well, if we follow the pattern over here on the numbers, my next number would be A sub 1. So this equation would be equal to A sub 1. So what that means is the A sub 0 right here is our initial number, whatever it is. The times 2 accounts for the doubling. The plus 5 accounts for the add 5. And when we do all of that to our initial number, we will get the starting number after one round, which is that. All right? So we did calculate what it was if A sub 0 was a 5, and that means that A sub 1 would be a 15. And then let's do this again. We'd start with 15. We would multiply by 2, that's 30, and then we would add 5, that's 35. And let's think of the equation. What did we start with this time? Well, we started with A sub 1, right? Our initial, our starting number for round 2. We doubled it, so times 2. We added 5 plus 5. And when we do all of that, that's going to be our result from round 2, but also it's going to be our start to the next round, which would be A sub 2. Our start of the next round, which is 35. Okay, let's do one more. And let's see, that means we start with 35, double it, add 5. 35 times 2 is 70, plus 5 is 75. And this would be what we started with, A sub 2 doubled plus 5, and that's going to equal A sub 3. And we could just continue. We could say, okay, A sub 3 is 75. 75 times 2, that's 150, plus 5 is 155. And so what we really did was we took our initial number, A sub 3, we doubled it, we added 5, and that's going to be equal to our next number, which is A sub 4. So we've got a nice pattern here. Would be good to just write an equation that would stand for any number that we chose. So let's see if we can do that. Well, we need an initial number, and it could be anything. It could be 5, it could be 10, it could be 18, it could be 7, it could be anything. So what we're going to do is we're going to use A sub I for our initial number. A sub I for our initial number. And then we're going to do what we do to that, right? We're going to take that initial number and we're going to double it. So A sub I is going to be doubled, and then we're going to add 5 to it, and that's going to equal our next number. Well, isn't our next number a sub I plus 1? That would be the next number. I mean, that happened over here. It was a sub 0 plus 1, which is a sub 1. A sub 1 plus 1, which is a sub 2. A sub 2 plus 1, which is a sub 3. So that equation tells us whatever my original number is, a sub I, I'm going to double it, I'm going to add 5, and that's going to be equal to my initial number plus 1, which is the next starting number in the sequence, and also the result. Okay, so there is our recursively defined sequence, and we can use that to help us find some answers here. Okay, when we write these sequences, let me wipe this out. I don't know if I want to wipe it out. I'll use this. When we write these sequences, the recursively defined sequences, we want to say what our starting point is, or an initial starting point. So we would say this: a sub 0 is whatever we want it to be. In our case, we said it was a 5. A sub 0 is a 5. And then we would write our equation that we came up with, which was a sub I plus 1, which is the next result, or the first result, or the next initial number, is equal to 2 times a sub I, our initial number, plus 5. And then I would want to say, as long as I is greater than or equal to 0. It's got to be a positive number. All right, so there is our recursively defined sequence, which you also see right here. So we're going to use that we just figured out, and we're going to use a generic initial value of a sub 0. That's going to be our first number. It's going to be a sub 0. We don't know what it is. We're going to call it a sub 0. And then we're going to find a formula for a sub 1, 2, 3, 4 in terms of that a sub 0. All right, so let's do that. So we're going to use this up top here. We're going to use this to write a formula or equation for a sub 1, a sub 2, a sub 3, a sub 4. All right, so a sub 1 is going to be this part. It's going to be our next value, or the result, and the next starting value. So that's a sub 1 is equal to 2 times a sub 0, which is our initial value. Remember, using a generic initial value of a sub 0. And a sub I is our initial value, so 2 times a sub 0 plus 5 is equal to our next starting value, which would be a sub I plus 1. A sub 0 plus 1, which is a sub 1. Okay, there's the first one. How about a sub 2? Well, a sub 2 is going to be, that's a sub 1 plus 1, if we look here. A sub 1 plus 1. Well, a sub 1 plus 1 is a sub 2. And 2 times a sub 1 is this. This is a sub 1. So it's 2 times a sub 1, which is 2a sub 0 plus 5. Okay, and then if we, one more thing. 2 times a sub 0 is this part. We still have to account for that plus 5, which is back here, so that's a plus 5. So if we simplify, we get distributive property 2 times 2a sub 0 is 4a sub 0 plus 2 times 5 is 10 plus 5. And all in all, I'm running out of room, but it's 4a sub 0 plus 15. Get in there. All right, that's a sub 2. All right, I'm gonna remember this because I'm gonna need that for the next one. Let's get to a sub 3. A sub 3 is equal to, well, it's equal to 2 times a sub 0. So this is 2 times a sub 2 plus 5. And what is a sub 2? Well, a sub 2 was this. So it's 2 times 4a sub 0 plus 15 plus 5. And let's see where that gets us. That gives us 8a sub 0 plus 30 plus 5, which would be 35. So let's just back this up, make this a 35. 8a sub 0 plus 35 is a sub 3. And we can continue. A sub 4 is equal to 2 times a sub 3 plus 5. What is a sub 3? Well, it's this. So this is 2 times 8a sub 0 plus 35, and then plus 5, which would give us 16 a sub 0 plus 2 times 35 is 70, plus another 5 is 75. 16a sub 0 plus 75. And that would continue, right? This would be a sub 4. That's what we would start with, etc. All right, so using a generic initial value of a sub 0 and the recurrence relation given, there are the formulas for a sub 1, 2, 3, and 4. All right, more on this coming up. We'll keep practicing. That is a recursive sequence, and I hope that helps. We'll see you again next time.